Hey guys, today we're going to learn how to factor a difference of squares. Let's do it. Alright guys, so up until this point you've probably noticed that whenever you multiply two linear binomials together like this using the distributive property, you end up with a quadratic trinomial. And so just to recap, the distributive property tells us that x times x would give us the x squared, x times 3 gives us the 3x, 2 times x gives us the 2x, and 2 times 3 gives us the 6. And then we can combine like terms in the middle here, and the positive 3x and the positive 2x gives us a positive 5x. And so usually this is what happens. You multiply these two binomials together and you get a quadratic trinomial. But I want to show you sort of a special case here. So let's say we have two binomials, one's x plus 3, and we're multiplying that by x minus 3. Well, the distributive property tells us that we have x squared, and then minus 3x, right? X times negative 3, and then plus 3x, 3 times x, and then minus 9, positive 3 times negative 3. And then what happens when we go to combine our like terms in the middle is you'll see that they cancel, right? Negative 3x plus positive 3x happens to be 0. And so we're actually left with a quadratic binomial. We're left with only 2 terms, and we're used to seeing 3 terms. And so what this is called, this is a special case of polynomial that we call a difference of squares. And why is it called a difference of squares? Well, difference means subtraction, right? So we have a difference of 2 perfect squares. X squared is a perfect square because x times x is x squared, and 9 is a perfect square because 3 times 3 is 9, right? Your perfect squares are 1, 4, 9, 16, 25, 36, and so on, right? And so when you have a situation like this, so let's say we had a difference of squares like this, for example, b squared minus 49, we can actually factor this. Usually we're used to factoring trinomials that look like this, but in some cases we can factor binomials. And so as you sort of saw where this binomial came from, it turns out we can factor this by taking the square root of the first perfect square. So the square root of b squared is b. So we'll put a b in each of these sets of parentheses. And now I need a plus sign and a minus sign. And again, the reason we need this plus and minus sign is because we need to get these middle terms to cancel. And so now we're going to take the square root of 49, and that's 7, and we're going to put that in the other space here. And so this is the factored form of this binomial. And again, if you need to check, you can always use the distributive property, right? B times b is b squared, and then b times negative 7 is negative 7b, but then we have positive 7b. 7 times b is positive 7b, and so those middle terms will cancel out. And then we have the positive 7 times the negative 7, which gives us the negative 49. All right, so this is how we factor a difference of squares. So for example, maybe we had something that looks like this. All right, so you have to recognize that I have 2 perfect squares here. C squared is a perfect square, and 144 is a perfect square. And I'm taking the difference, right? Subtraction. And so I'll take the square root of this perfect square, that's just c. And then I need a plus and a minus. And the square root of 144 is 12. And there we go. All right, so now at this point in your sort of algebra career, you're probably only going to be working with quadratic binomials that are differences of squares. But I want to note that they don't have to be quadratic. This rule actually works for any difference of squares, even if it's not quadratic, right? This is to the x is to the fourth power here and not to the second. So this is not a quadratic binomial, but it's still a difference of squares. 4x to the fourth is a perfect square, and 16 is a perfect square. And so I can still factor this in the same way. Now the square root of 4x to the fourth, I know is 2x squared. So I'm going to put 2x squared into each set of parentheses. And then of course my plus or minus 4. Alright, so this factoring process works even if your binomial is not quadratic. As long as it's a difference of squares, it'll work. And we'll do one more for good measure. Okay, let's say we had 16a to the 6th minus 25. Well, I know this is a perfect square because I know 4a to the 3rd times itself gives me 16a to the 6th. And so I will put that in each set of parentheses. And then the square root of 25 is of course 5, so I will do 1 with minus 5 and 1 with plus 5. Alright, and that's all there is to this one.